Okay, can you see my screen?
Yes.
Okay. Um, today we're going to start the shell programming. So if you're very familiar with shell programming, you don't want to waste time, it's okay. You can just leave. Anyway, this lecture will be recorded and I will upload it to YouTube and share the link with you. Now let's start it. We will not be able to finish this lecture. Let's just finish half of them. Uh, okay. So first, shell programming. In these two lectures, we're going to introduce how to use B shell to do some programming work. The shell is a programming language that executes the script in the interpretive mode, which is running the script line by line. So it's different from other languages like C language or Fortran or others. In C language, um, it's not interpretive mode. It's you need to first compile the source code in C, and you will generate the executable file, and then you run the executable file. However, in shell, you don't compile. You just run it line by line. This is called interpretive mode. Um, okay, so here are some difference between a scripting language and a programming language which can be compiled. So for example, for let's see, C, Java, or some other languages, so most of the language, you need to compile them with a compiler and generate a executable file. This executable file can be run in your system. But for example, if you compiled this source code in Windows, then most probably you can only run the executable file in Windows. If you compile it in Linux or Unix, then you can run it in Unix. The good thing is if it's compiled, um, that means usually there's no error or significant troubles with your code. At least it passed through the compiler. Of course, there might be some bugs. There are always some bugs in most of the programs. However, the compiler can check some basic errors for you. If you pass the compiler, uh, then at least there's no basic errors in your script or in a source code. However, the disadvantage is it's not very, let's say, portable or compatible. For example, if you compiled your, let's say, C++ program in Linux, which is Ubuntu, and you want to use this executable file after the compilation into another, even let's say another Ubuntu computer, there might be some troubles because sometimes when you compile the things, it needs some many other things like libraries in this computer. Maybe this computer has this version of library, the other computer it has a different version of library, or even it doesn't have this library, then most probably you will get some troubles. So that's the advantage and disadvantage of compiled code. For scripting language, you don't have to compile it. Um, so for those scripting language like the shell, you just write the source code in the file, and when you execute it, you're not going to execute a executable file generated from the source code. Actually, the source code itself is executable file. So you execute the um, your script line by line. So the disadvantage is you don't have a like a checker. before you run the script. So it might run into a trouble, which is in the half um, of your script. So maybe first 200 lines of your script, it's fine, but in next line, the line 201, you get some troubles. Um, so that's a disadvantage. Nobody is going to, or no compiler is going to check the basic errors. You have to run it and then figure out if there is a error. The advantage for scripting language, at least for Bash, is it's very compatible. If you write a Bash script, you can run it on this computer or another computer if it supports Bash platform. For example, even most of the time, even you write the bash in a Mac, you can run it in different versions of Linux. So that's very compatible. Okay, so in this class, we're not going to learn any program which can be compiled. We're going to just learn the script language, which is bash. So there are different levels of scripting. So the level one is just to run some simple commands, or you type some simple commands in a file. And then when you run this script, it runs the commands line by line. So second level, you can use some variables and positional parameters in your script. That gives more possibilities. You can process some files without hard coding the file name in your script. So you can pass some file names as variables. So the third level, using complex branches like if or loops such as while or for loops, then you can logically create very complicated logic um, code. So you can run complicated tasks in the shell script. Okay, so let's start from the first level. We will start it from very easy script and get it more and more difficult. So, like any other languages, when you start to learn a language, the easiest program is always maybe Hello World. So let's see how to make a Hello World program in Bash. Okay, so I'll use this terminal. Now, first, let me check. Okay, I'm in this folder. First, I'll come to the test folder. Let me clean everything. Now I have a clean folder in my test, and then we will start to run something. First, hello world. The thing we can do is we can use any text editor to create a file, which is a text file. So have you tried any text editors like VI or other editors in Linux? Okay, how to see your answers? So are you familiar with any editors in Linux? Where to see your comments? So here. Okay, good. Okay, let me keep this window here. Okay, Since you all have tried either VI or other editors, then we can do it together. So first I will use VI. So now I will create a file. Let's say hello.sh. Here we're talking about extensions of a file. In Windows, when you see a .exe file, usually you know it's executable file. So you can double click and execute the file. That's the default extension for executable files in Windows. However, in Linux, the extension itself, it doesn't give you too much information. So we can create this file as hello.sh. We can also create in another extension, for example, hello.txt. It doesn't matter too much. The executable permission is not given by the extension. It's given by the permission. If you remember, in last class, we have learned change mode. If you give it permission of executable, then that's executable, no matter what's the extension. So now let's create the first program, hello world. So by default, when we create a bash script, the first line is pound, and then with exclamation mark /bin/bash to say, to inform the users that this is a bash script. But actually, if you don't type this line, it's still okay. You can still execute the file. But this line itself, it doesn't do anything. Okay, now let's type the easiest program, which is output hello world to the screen. So here we use echo. Echo is like print or printf in C language. So it prints something on the screen. We use double quote to let echo know we're going to echo or output hello world. Hello world. Then let's save it. List, you will see there's of hello.sh. If you ls-l, you will see we have read write permission, but we don't have execute permission. Let's first give it executable permission, because if you don't give it the executable permission, you can't run it. So it will say permission denied. So let's change mode plus X to this file. Now let's list it again. See, this X means the user, which is me. I have the permission of executed. So now let's execute this hello.sh. And the function of this script is just print hello world on the screen. So that's very easy. This is our first program. And of course, in you can use some other command to change the permission. You can use a number mode 700. Talking about the path, when you run an executable permission, you have to use a path. If you just run hello.sh, it will say command not found, because it doesn't have path. You need to give a path. For example, now it's in the current folder, so you can use .sh, which means current folder. So the terminal will find the hello.sh in your current folder and run it. This is relative path. Of course, you can use um, absolute path, which is home of my current folder. Okay, my current folder is users Lindley test. So this is the absolute folder, absolute path, and then followed by the hello.sh. It executes this executable file. So, so remember that the path is very important. You need to specify where is the executable file before you execute it. Okay, next. It's a convention to write this line in a bash script, but it's not necessary. Another thing is sometimes you may see the first line, which is not bin bash. It might be bin Perl or bin Perl 5, or sometimes bin C shell or other indicator. So that simply means um, this script is written in Perl or some other, or Python or some other language. So the first line itself, it doesn't execute anything. It doesn't do anything. So let's say if we delete the first line, it still works very well. It will give you hello world. So this is just a convention. Another thing is, as I said before, the executable permission doesn't mean it has to be .sh or some other extensions. Even it's not in a .sh, it can still be executed. Let's try if I move hello sh to hello txt. Let's see if we can execute it. I think we can, because based on my understanding, it doesn't matter what is the extension. Yeah, so even you change it to hello.txt, it can be executed. Even you remove the extension. Let's say now it doesn't have any extension. Still, you see you have the executable permission. Still, you can run it. So that's the same thing. Okay, so this is another point. The extension of a file is not necessary for executable permission. Okay, so now let's see a little bit more complicated bash program. In the first program, we just run it in one line or one command. Now let's create or increase or modify the first program and make it more complicated. We can add several different lines or commands into a script to make it more complicated. Okay, still this file. In this script, we echo hello world. Now let's do something else. For example, make the IR, make a directory of folder 1. And we can make another folder. Let's make 2 folders. Maybe, okay. And then what else? Let's do something else. For example, create a file, Apple orange into a file. You remember this redirect sign? It will redirect the output of this command into a file. Let's say it's a fruit.txt. Maybe let's put it here. Okay, now you have a little bit more complicated um, script. It runs four command. First, it create it echo hello world, and then it create two folders, and then it's creating a fruit.txt. Let's save it. We still have permission to run it. You have X here. Now let's run it. Hello. So first, it runs hello world, and it will execute other command. It created the folder 1, folder 2. It created the fruit.txt. Let's see this fruit.txt. Okay, so in the fruit.txt, you have apple, orange. So this is what we do um, by combining several commands into a script. So this is just the example. So you can imagine in the future, if you want to frequently do something related to folders or files, you can simply use a script to combine those commands in executable file so that you don't have to run it many times. And of course, later on, we'll make it more and more um, elegant. For example, if you want to create 100 folders, so what do you need to do? Okay, so now let's start another concept, which is variables. So for shell variables, it's very easy to create a variable. In C or most of the languages, when you declare a variable, you need to first declare the type of the variable. For example, in C, you need to declare the data type, which is perhaps int or float or characters or string for your variable. However, in shell, you don't have to declare the data type because it only supports one data type, which is string. So now let's try. So first, the way to declare a variable is this symbol, equal sign. Let's say we want to declare variable a, so you can let a equals to 3. Then you have a variable a, and the value of a is 3. If you echo, if you want to get the value of a variable, you need to use a dollar sign. So $a means you echo the value of a, which is 3. As we said, it only recognizes, actually the variables are only string data type. So let's declare another variable, which is b, banana. If you echo b, you will see the content or value of b is banana. And you can, let me see, you can unset, you can use unset commands to remove a variable from the shell. For example, if you unset a, then let's echo a again. You will see it's empty. There's no value for a because you unset a. Okay, let's give a the value again, which is apple. Echo a, so a is apple, so b is banana. So another feature is you can concatenate the two strings by just type them side by side. For example, if you want to echo a, b, so you will have apple, banana. And you can also assign another you can assign the value of A and B to another variable. For example, C equals $A, $B. Then C will be apple, banana. Okay. Let's see what else. Okay, that's it. And shell variables can be evaluated by using curly braces around the variable name. Sometimes you may get, or the terminal or bash may get confused. Let's say, for example, if I want echo banana is good, so $B, it's banana is good. So what happens if I type in this way? Do you get banana is good? Actually not, because $B, um, in this command, it doesn't recognize B as a variable. It recognizes B is good as a variable. So B is good for this variable, it doesn't have any value, so you get empty. But if you use the curly braces to quote this B, then that's very clear for the bash to know, okay, now you're first trying to echo the value of B, and B is the variable, and then followed by is good. Then you will have banana, it's good. So this is useful because sometimes you want to echo um, some values followed by some other characters, for example, .txt, then you have to use this curly braces. You will get banana.txt. And if you don't have this curly braces, sometimes batch is confused and you may get some error, unexpected. So it's very good habit to keep the curly braces when you try to get the value of a variable. Let's see. Okay. So question, are the variables case sensitive in bash? Let's try. Echo $A, you have apple. Let's see if it's case sensitive. If it's a capital A, you get nothing. So that means yes, it's case sensitive. Another concept, single and double quote. So sometimes we need to use, excuse me. Sometimes we need to use quote to, let's say, assign some values to some variables. But you can use single quote or double quotes. However, they mean different things. First, let's check single quote. Let's say now I want to assign a value to, let's say, fruit. Now, fruit is my variable. I want to assign a value of apple, banana. I want a fruit to have the value of apple space banana. So if we do this, does it work? You can make a guess. So if you assign value apple banana to fruit, so what will happen? It will say the command of banana is not found. And if you echo fruit, you will see it's empty. So simply the bash will take this as a command. After a space, you have another command, but the banana is not a command, so it doesn't execute the whole command. So what you can do is you can use single quote or double quote to quote the value or a string which contains a space or other special characters. Now, it's successful. If you echo the value of fruit, you will see the value of fruit is apple space banana. And of course, in this case, you can also use double quote and give the value to fruit. Maybe let's add more. Apple, banana, orange, so that you see the double quoted values are assigned to fruit. If you echo fruit, you will see now the value has been changed to apple, banana, orange. So it seems like either single quote or double quote, they works in this situation. Now let's see something different. What's the difference between single and double quotes? Let's take another example. Now, if I assign a value, let's say still apple and banana. Let's first use double quote. But this time, I'm not going to type apple and banana. I'm using the value of $A and value of $B. Do you remember what is the value of A? It's apple. And the value of variable B is banana. So by doing this, we hope to assign the value of fruit to be apple space banana. Let's see if it works. Yeah, it works very well. What about single quote? If we assign single quote $A space $B to fruit, so what will happen? Okay, so that's the difference. So when you use double quote, the variables in the double quote will be resolved before you run the command. So first, the bash will recognize, okay, this is a double quote. Now let me see, is there any variables in the double quote? Yeah, there's a variable A and variable B in the double quote. Now I need to resolve it because it's $A means I need to resolve or get the value of A. Then the bash will first replace $A as its value, which is apple, and replace $B as banana. And then it will assign apple space banana to the variable fruit. So you get this value for the fruit. However, if you're using a single quote, it doesn't resolve anything. It just assign exactly what you typed in the single quote to your variable. So you get $A, $B. It doesn't resolve the value of $A or $B. So that's the difference. Okay. Now next, how to do math in Bash. Remember that we have talked about the data type of variables in Bash. They're all strings. So for example, if I assign number 1 to be 2, number 2 to be 5, actually, of course, when you echo it, the value is 2. However, this is not an integer. This is a string. If you want to do some calculations in Bash, it's a little bit complicated. It's different from C or maybe Java or something. You can just type maybe A equals to number 1 plus number 2, then um, you will get the sum of 2 and 5, which is 7, and assign 7 to uh, the variable A. However, in shell, you cannot do this because if you do that, you will simply get first number 1 is 2, and then a plus sign, then number 2 value, the value of number 2 is 5. You will simply get strings. So 2 is a string, 5 is a string. They are connected by another string, which is this plus sign. So this is the difficulty of running a mass calculation. There are some ways to do the calculation. Here it gives you arithmetic expansion, which can do integer calculations. I'm not going to introduce this thing because it's not very useful. It's a traditional way of doing some calculations, but we don't use it too frequently. It's not very useful. So this is the first way you can read it. The second way to do a calculation is using a tool in the bash, which is BC, the B shell calculator. Okay, this is a tool. It's like a calculator in the command line. If you type BC, enter, now you're in the interface of the B shell calculator. If I do a simple sum, which is 1 plus 2, you will, after you press the enter, you will get the answer, which is 3. Now let me try 1.5 plus 2.3. You get the answer. It can do some math, like almost all the math functions. For example, if you multiply, then you get the answer. But the thing is, by default, it doesn't give you a high accuracy. If you want to use a BC or B shell calculator to do high accuracy calculations, you need to specify the precision, and we will see it later. First, I'll quit from the BC. However, in a shell script, you can't run a BC, right? You don't want first let users to go to a BC interface and do some typing and then get the result. So the easiest way is using the redirect sign. For example, you can echo 1 plus 2. Then the answer, the result of this command is 1 plus 2 on screen. You don't have to print it on screen. You can use the, actually it's a pipe. You can use a pipe to give the output from this command as the input for BC. Then the answer is 3. So by using this command and pipe it to BC, you will have the answer of a calculation in shell. Let's do another thing. For example, 2.2, 2.3 times 1.56. You will get the answer. Sometimes you want to make a high precision calculation. Here you can use a dash L, means a long precision calculation. You will get the very long precision because in this case you only have 4 digits, so you will see all the 4 digits. Okay, so another thing is now you can run this command But do you remember the previous problem? For example, if you want to assign the sum of two numbers as a value to a new variable, can you do that? Here you just output uh, the sum, but how to assign this value to another variable? Um, Here we need to introduce another useful tool, which is expanding bracket. This is the expanding bracket. Um, this expanding bracket function is, it will first execute the command inside this bracket and then do the rest of the command. For example, a equals to, okay, let's start from this command. The previous command, you remember the value of this calculation is 3.588. We want assign this value to, let's say, a variable of a. You can use a equals to $sign parentheses. Okay, so this is expanding bracket. So in this bracket, you have a command or a cup of commands connected by pipe. So the bash will first run the things in this bracket, and you know the value is, the result is 3.5 something, and then it will replace the entire expanding bracket into the result of the command, and then it will run a equals to 3.588. If you echo $a, you have this value here. Let me see, anything else? Okay, so there's another useful command, which is scale. So sometimes you want to specify how many digits do you want after the decimal point. So you can use scale. Let's say scale equals to 1. Okay. Scale equals to 1. It doesn't work. So, for example, if you want to specify the digit after the decimal point, you want 3 digit after the decimal point, you can use scale equals to 3, and then you have 3 digits. Let's try scale equals to 4, because this number only have 3 digits, so it doesn't work. But let's make it more complicated, give it more digits. Okay, in this case, if you have a lot of digits, if you use scale equals to 4, it will give you 4 digits after the decimal point. If you want just 2 digits, it still gives you 4 digits. Mm-hmm. Okay, I don't know what's wrong with the scale. Maybe it has a limit of the lowest accuracy. So if you specify the accuracy to be too low, it doesn't give you that low accuracy. For example, in this case, um, even you specify the scale is 2, still it gives you 1, 2, 3, 4, 4 digits after the decimal point. I didn't read the scale option carefully, but one thing perhaps can explain is if you specify the scale to 2, it will first count the precision in your numbers So in this number, you have 5 digits precision. In the other number, you have 5 precisions. So maybe it gives you, if the accuracy you specified in scale is too low, it will give you um, the same accuracy as your input number. This is my guess. So it's 5 digits. So you will have 5 digits. So it doesn't allow you to give very low uh, digits. Let's say if it's 7, it gives you 7 digits. So if you give a high accuracy number, it will give you exactly the number of digits that you specify. But if it's too low, it doesn't work. Okay, anyway, so this is another small function of scale. If you're interested, you can do some research, see how to use scale. When the scale is specified as a very low value, what happened? So why it doesn't give you a certain low value you specify, like this. Even I specify 2 digits, it give you 4 digits after the decimal point. Okay, read command. Like other languages, sometimes when you have a program, you want to read something from the terminal. So the read command can be used as this function. For example, you want to read, let's say, a value for a variable which is file. Of course, you can assign the value to file, let's say folder 1. Then if you echo the value of file, you get the value to be folder 1. But sometimes you need some, let's say, interactive mode of typing the file name. Then what you can do is you can read file. Then if in the script or in the command line you run this read followed by a variable name, then it will pops up an interface between the script or command line and the user. So the user needs to type the value of your variable. Let's say folder 2. Now, after running this read command, you will have a new value for this variable. It's folder 2. It's assigned by typing it. Okay, so it's very useful when it is in a executable file. For example, in our hello world, let's try to do it. Read name. Okay. Maybe let's first echo input name, and then read, and then followed by name. Name is your variable, and then we will say hello name. Exclamation. Okay, so now let's run the hello again. So first you output input a name, let's say some name, hello banana. Oh, okay, because okay, now let's see what it runs. First input a name, we input banana, then it execute hello banana. Uh, then it want make folder 1, but the folder 1 is already existing, so it give you a warning and making another folder 2. So anyway, it will run your command by reading a value for a variable. Okay, so this is calculating sum of two numbers. Um, Okay, let's see this program. You can echo, input the number one, read the number one. You can give a value of number one, and then the same thing for number two. And then sum equals to using BC to do the sum of the two numbers. And then echo number one plus number two is sum. So that's a simple program. It's a calculator of calculating the sum of two numbers. And here we use the expanding bracket. Shell parameters. Sometimes we need to specify some parameters. Let's say positional parameters. The positional parameters are assigned from the shell's argument when it's invoked. Position parameters may be referred as $n when n consists of a single digit. Okay. Let's say let's modify this script. So this time, let's echo. Okay, I'll delete those two lines. So I'll echo $1, $2. So let's make it clear. First parameter, $1. Second parameter, $2. So here, $1 means the first parameter. $2 means the second parameter. So here, hello. Now, when I run the hello, I'll follow the hello by some positional parameters. Apple. So that's the positional parameter. The first parameter is apple. The second one is banana. Then you will see first parameter, apple. Second parameter, banana. So simply in this script, you're trying to get the values of the positional parameters by using $1, $2. Of course, you can follow the command by a lot of parameters. You just increase the number $1, 2, 3, 4, 5. That's the usage of using positional parameter. Some special parameters. $number. It's the number of parameters passed. Okay, now let's try it. Echo $number. So we'll say $number parameters are passed. Okay. So let's run it again. This time, we give two parameters to hello. It will echo first parameter apple, second parameter, and then two parameters are passed. Now let's give it another parameter. Now it has three parameters. You will see three parameters are passed. So $number indicates the number of parameters passed. $0 gives the name of the shell script. Okay, now let's try code $0. $0. Let's run it again. So you will see $0 is .hello, which is here. So this is $0, the zeros parameter, which is a command itself. And apple is the first parameter. First parameter is apple. Second parameter is banana. Third parameter is orange. Okay, so $* gives a single word containing all the parameters passed to the script. Okay, $add gives something else. Okay, you can try those different special parameters by yourself. Make some script and try them and see what happens if you use all of these. Let's see, what else? Oh, okay. So here it gives you a list of all the positional shell parameters. Please try all of these and see how to use them. Okay, so that's all for today's class. We have a on-class test, but it's an online course, so we don't do it. We don't really do it in class. So I'll assume you will do it after the class. I will check it on Monday. So on Monday, everyone, please run your script by programming a script which calculates the sum of two numbers, use shell parameters to pass the value of two numbers. Spend some time, try all of these positional parameters and use it to calculate a sum of two numbers. And in Monday's class, please show your script and run it one by one. So that's your assignment. Okay, so that's all for today. So do you have any questions?
Oh, yes, thank you.
Okay, so if you don't have any questions, that's all for today. So I will stop sharing and stop recording, and I'll upload the recorded video to YouTube and share you the link. Okay, see you next time. Bye.
Bye, Dr. Lee.
Bye.
Thank you. Bye-bye.
Bye-bye.